Geometric series, 3 examples. Geometric means, find the first term and find the sum using sigma notation. Let's get started. Example number 1. Find 4 geometric means between 243 and 32. And I have the following steps, 3 steps with some formulas on the side. R is the common ratio, A1 is the first term, and so on. So if the first term is 243 and the last term is 32, as you could see, when it says find the number of terms, we're going to end up with 4 in the middle, 1 at the end, 1 at the beginning. That should be 6 terms. The common ratios are, that's the first term, and that's the nth term. The general form for any term is a sub n equals a sub 1 times the common ratio to the power n minus 1. So what we have here is, as we mentioned, n has to be equal to 6. And let me explain more. Because there are 4 terms between the first and the last term, there are 4 plus 2, the first term and the last term, that's the 2, or 6 total terms. In other words, n equals 6. And the picture at the bottom side shows that we have 6 terms. Step number 2. Find the common ratio. To find the common ratio, we have a sub n, the general term, the nth term, equals a sub 1 times r to the power n minus 1. The nth term, in this case the 6th term, is 32. So let's use that as my last term. 32 equals the first term, that's 243. So in this case I'm using n equals 6. So times r which is unknown. That's what we need for step number 2, find the common ratio r to the power n minus 1, which is in this case 6 minus 1. That means we have 32 equals 243 multiplied by r to the power 5. Dividing both sides by 243, I will have 32 divided by 243 equals r to the 5 to the 5th. Taking the 5th root of both sides to solve for r, I will have the 5th root right here and the 4th root right here of 32 over 243 equals the 5th root of r to the power 5. This will give me on the left the 5th root of 32 over the 5th root of 243 equals, the right side will be just r by itself. And to do the math, using the calculator, because sometimes students will go like, how do I find the fifth root? This is how you find the fifth root. You just type 32 to the power 1 over 5. To be on the safe side, use parentheses for everything right here, as you could see. Hit enter, and those are the keys that I'm using. You will get 2. And the denominator is 243 to the power 1/5. That means the fifth root of 243. Hit enter, and you'll get 3. The reason why I'm doing the numerator by itself and the denominator by itself is to avoid decimals. If you use the fifth root for the whole thing as a fraction, you're going to get 0.6 repeating, but 0.6 repeating is 2/3. So we have 2 over 3. Let's go back. So R is 2/3. So now so far we have R and we have N. N equals 6, the number of terms, and R equals 2/3. The third step says use the common ratio R, which we found as 2/3, to find the 4 geometric means. That means the 4 geometric terms in the sequence that we have, the missing terms. It's a geometric sequence. So to go forward, I will have to multiply 243 times 2/3, and I will get 162. And I keep doing that times 2/3, and I will get 108. I take 108 times 2/3, and I get 72. Take 72 and multiply it by 2/3, I will have 48. If you take 48 and multiply it by 2/3, you will get 32. And that should do it for number 1. That's how you find the geometric means. As it shows step 1, step 2, step 3. You need to find the number of terms, the common ratio, and once you find the common ratio, you can just use it and move forward from the first term. To make sure that you're doing it right, once you get to the 48, this right here, make sure that you double check, multiply by 2/3. If you get 32, that means everything is fine. Example number 2. Find the first term in a series. To find the first term, we have A1 in the geometric series or sequence, for which the sum is given to me as 21.3125. And we have 5 terms. We're summing 5 terms, so this n in this case is 5, and we are given the common ratio 1/2, and we need to round if we need to the nearest tenth. This is the general form, the nth term, and that's how it looks like, where R is the common ratio. That's the first term, A sub 1, and that's the nth term. A geometric series compared to geometric sequence is the sum. Sequence means terms. We use commas. For geometric series, we are looking for the sum. When we add the terms in a geometric sequence, now we're speaking series. Partial sum of n terms, that's the meaning of partial sum, if it's not going to infinity, if we have a1, the first term, the common ratio, and the number of terms, we could use this formula. As you could see, this one uses a1. However, instead of a1, or instead of n, we have a sub n, the general term, the nth term, we use this formula that has a sub n. They're both the same. If you replace a sub n with this right here, that's why a sub 1 shows up. And this simplifies to r. Anyway, we're not deriving it. I just want to show you that we have two types. It depends on what you are given. Here's the problem. Without all the notes, so you could do it step by step. So we have the sum formula that we're going to be using, and on the left side, step by step, I have the following. Instead of s sub n, we're using the sum, which is this much right here. So the left hand side of this formula will be 21.3125. Right hand side is a fraction, and we have a sub 1 minus a sub 1 again multiplied by the common ratio. In this case, it's half to the power n minus 1. Well, in this case, n is 5, so I'm going to write 5. I mentioned n minus 1. It's this formula uses n. This formula uses n, not n minus 1. So 5 over 1 minus r, and that is 1 minus half. I'm going to separate this so I could write in 2 columns to write all the steps. So we have 21.3125 equals a sub 1 minus 1/2 to the power 5. That means 1/2 times 1/2, 5 times. That's going to give me 1 over 32. Instead of saying a1 times 1 over 32, I'm going to say 1 over 32 multiplied by a sub 1. You know, imagine if a sub 1 is x. Instead of saying x times 5, we could say 5x. It doesn't look right. I mean, it's fine, but it doesn't look good to write x5 instead of 5x. Same thing right here. So the number, I pulled it in the front of a sub 1 instead of after. Over 1 minus half, which is half. Now, on the top part, I need to combine or subtract these two terms. So I need a common denominator. This right here is like 1 a sub 1. But I could think about 1 as 32 over 32. A sub 1 minus 1 over 32 a sub 1 over half equals, let's take the equal and put it next to the fraction, and on the left side is 21.3125. Now I do have a common denominator on the top in the numerator right here, so I could combine them. 32 over 32 minus 1 over 32 will be 31 over 32. So what I have on top is the following. Let's make this clear as a fraction. 1.3125 half right here, and this right here is the main fraction bar. On top, I do have 32 over 32 minus 1 over 32. That's 31 over 32 multiplied by A1. Moving to the right, I have 21.3125 equals 31 over 32 A sub 1. Let's change the division to multiplication and flip the denominator. That becomes 2 over 1. Simplifying, I could divide this by 2, get 1. Divide this by 2, I get 16. So I have 21.3125 equals 31 over 16 A times 1. Multiplying both sides by 16 over 31 to leave A sub 1 alone. On the right side, I could see this cancels and this cancels, so it's like 1 over 1 of A sub 1. So the right hand side is A sub 1, and the left hand side, you could think of this as over 1 and use a calculator to multiply 16 times 21.3125 divided by 31. The answer is 11. So the first term is 11, and that's what they want. Find the first term of the series given to me. Why they call it series? Because you are talking about sum, not just terms. That is example number 2. This is how you multiply using the calculator, using parentheses, open parentheses. As you could see, the key is right here. Open parentheses, type 21.3125, close parentheses, multiply, open parentheses 16 over 31, close, and hit enter. And that's how I got 11. Example number 3. Sum in sigma notation. That is the sigma notation, as you could see right here. So we need to find the sum. And if we have to round, we'll be rounding to the nearest tenth. What's a geometric series? The geometric series is the sum of terms of a geometric sequence. Partial sums, it depends on what you are given. If you have A1 and R and N, use this formula on the right side. If you have A1, R, and not N, A sub N, use this formula. They're all about the same. Except tiny difference by if you, in the second one, you replace A sub N, as I mentioned earlier, with this form. After you simplify it, you get the one on top. Now, number 3. Without all the notes in our way. To find the sum, we'll look at the following. We need to find A sub 1, R, and N first. Let's do that. In the first term, we have k equals 5. We have k equals 5. And that is right here. So k takes values, that's this k right here on top, takes values from 5 to 12. 5, then 6, then 7, then 8, all the way up to 12. That's the meaning of it. So if you want to write in expanded form, you use 5 for the first term. To find the second term, you use 6 for k, and so on. Therefore, let's take this off. That's a highlighter. Therefore, we have a sub 1 equals, I'm using this form now, a sub 1 equals the first term, which is 3 multiplied by negative 2. That's my common ratio. You could see it right here. That's the base, to the power k minus 1. And in this case, I'm going to write 5 and subtract 1. So I'm using the nth term. This is the nth term in general, but to find the first term in our sequence, I used k equals 5 because that's my first k value that I could use. Simplifying, I have equals 3 times negative 2 to the power 4, which is 3 times negative 2 times negative 2 times negative 2 times negative 2 is positive 16, and that will give me 48. So now we have the first term in our sequence. Okay. Next, the base of the exponential function is r, because this acts right here as an exponential function. If you go back to exponential functions, f of x or y equal a times b to the x. That's how exponential functions look like. And exponential functions are somehow related to the geometric sequence, except some differences. And if you remember, if the base is greater than 1, we call it growth. If b is a fraction between 0 and 1, we call it decay. So the base that we are multiplying by, in this case, is not called b, it's called the common ratio r. So, therefore, so r is negative 2. Now there are 12 minus 5 plus 1, which equals to 8 terms. So n equals 8. Now keep in mind that when you look for the number of terms n, you need to follow this rule. 12 is this right here, minus 5 is this right here, and then you have to add 1. Because if you just subtract, you're just looking as distances. But if you add 1, you're looking at terms. How many terms? For example, if I'm going from 2 to 5, let's say 3 to 5. So if I start from 3 here and I go up to 5 here, using 3 and using 4 and using 5, you could tell that they are 3 terms. Using 3, that will give me a term. Using 4, that will give me the second term. Using 5, that will give me the third term, if I go from 3 to 5. But if you subtract 5 minus 3, you get 2. But we know we have 3 terms. So you need to go 5 minus 3 plus 1. So plus 1 is something important here to count them. Unless if you want to count them by hand. So you go like 5 and 6 and 7 and 8 and 9 and 10, 11, 12. Then you'll end up with 12. You end up with 8, as you could see. Let's double check. since I mentioned it, I'll just go over it. 5, 6, 7, 8, 9, 10, 11, and 12. Let's count. 1, 2, 3, 4, 5, 6, 7, 8. That's 8. It's not fully practical, but just to convince you that you have to add 1, because we're not looking at a distance between them. The reason why we want to use the formula or the pattern is, imagine if you go from k equals 5 right here to not 12 to 117. I don't think you want to count them by hand. So you need to follow this rule. Where 12 is coming from, the top number, 5 is the lower number or index, and add 1 to make it terms, not distance. Next, we're almost done. Let's close this and do the steps. So I have the sum of n terms equals a sub 1 minus a sub 1 multiplied by r to the power n all over 1 minus r. Let's make it fit. The sum of a terms, because we agreed that n equals 8, is equal to a sub 1, which we agreed on early as 48. So I'm gonna write 48 right here, minus another 48, let's put it inside parentheses instead of using dot for multiplication, times -2, that's my r. R is -2, which is right here. That's my r for this right here. And to the power n, which is 8. Let's extend the fraction bar over 1 minus -2 for r, which is going to change to 1 plus 2. One more step right here. Let's go to the right side. I don't think it's going to fit at the bottom nicely. So the left side is sub 8, and the right side is the following. Equals, I have 48 minus 48. Let's clear this up. Minus 48 multiplied by -2 to the power 8 using a calculator. That is 256. 256. All divided by 1 minus -2, which is 1 plus 2, and that is 3. Using a calculator for this, I have -40, 80. So the sum when k varies from 5 to 12 of 3 multiplied by -2 to the power k minus 1 came up to be -40, 80. And that should do it.
Thank you for watching. If you like this video, hit the like button and subscribe, and I'll see you next time. Thank you.